So good afternoon, everybody, and welcome to Future Tech Conference. You are just joining room 2, where we're going to talk about GraphQL. My name is Donald Hessing, and I'm the lead and head of Microsoft at Capgemini. Also joining this call is Arin Roy, who is Managing Solution Architect at Capgemini, and in his day-to-day job, quite busy with cloud-native development on Azure. In the next 30 minutes or so, we're going to discuss everything related to GraphQL. And we will start with a short introduction on why GraphQL exists, where it is coming from, and maybe most importantly, what problems it can solve. Then we will dive into the ability of the client to query for data it needs and the GraphQL type system and schema that sits behind the API. And lastly, we will discuss the GraphQL gateway and schema stitching techniques that allow us to stitch multiple microservices into a single API endpoint. But first, let's discuss GraphQL. Today, it is becoming more and more common to break down a monolithic architecture into small APIs that work independently. And this provides the flexibility as Microsoft Services supports an isolated part of the functionality. An example could be an API for products, inventory, cart, or customer pricing, for example, where each API provides its own data store, business logic, and of course, an API endpoint. And because of the isolation, they can be deployed independently, which provides agility and speed to deploy, and teams can deploy their API on their own cadence. But the microservices architecture also comes with challenges. And the number of microservices can quickly become a bottleneck for clients to query all the required data. And in many cases, it needs to query 10 to 15 APIs in order to retrieve the data for the specific page or for the mobile application. And this not only requires a lot of code to build and maintain, but it also gives challenges for the areas of performance and specifically for mobile applications because the number of API calls and the round trips can quickly become a bottleneck for the battery life of the device. A solution to this can be GraphQL. And GraphQL is a query language that provides a single endpoint for clients towards microservices. It allows the client to query the data it needs. And for this query to run and to execute, a server runtime is available at GraphQL, which basically processes the queries and then forwards the request to the downstream APIs. Examples of companies that provide GraphQL as an endpoint are Facebook, which is the creator of or the inventor of GraphQL, but also Twitter and Airbnb and Netflix are examples of GraphQL users. So let's have an example and a simplified e-commerce website. So here it's maybe a little bit overly simplified, but here you can see that there is a website with a profile and some products, and the products have comments and they have a description, and they typically also have an image or additional assets. And building this out by using microservices, each with their own REST endpoint, would result in something like illustrated on the right-hand side, where you can see an API for the users and user profile, for the cart of the user, the products, but also the reviews of the products. Now, again, this is a very overly simplified model, but in very common use cases for, let's say, social applications or e-commerce or maybe even websites, this can quickly result into 15 or more API calls. So the number of network requests and device, so the number of network requests and the device resources can eat up the resources of the mobile devices, resulting in very bad performance and potentially draining your battery of the device. When Facebook launched their mobile application in 2004, they faced quite similar problems in the development of the mobile application. And when they were analyzing their application, they found out that the number of requests towards the Facebook APIs and the amount of data that was going over the wire was basically the main bottleneck. So they were looking for a solution where the number of round trips was basically minimized and that they had the ability to query for the data that it was only needed. Because for their mobile application, there was a bit different data needs than, for example, for their global website. So they came up with an API technology called GraphQL, which they introduced in 2005, and they open sourced this in 2005, which allows the clients to request the data that it needs. And in this simplified model, you can see a similar GraphQL that in one query fetches the profile information. So let's say the user, the name and the image, but also the card and the number of products on the card and the products with their name, image, and the reviews of these of the products, but all in a single query towards the GraphQL API endpoint. Now, what we saw is that this website had a certain data needs, and this data needs was being queried by the web client, which then by the GraphQL gateway in this case was sent to the downstream APIs. But every client can have different data needs, and in this case, the query for the web is perfect because this exactly contains the data the web client would need. But if the same API endpoint would be provided to the mobile application and with the same query, then because of the mobile application and the form factor and the available space on the device, typically you would request too much information, right? Because maybe the product reviews was not rendered, or maybe not all the product details can be rendered on the mobile device. And let's say if this mobile application would query the same, then it would request too much information, which we also call out as overfetching of data. Now, the same principle applies to fetching not enough information, which is called underfetching. In this case, the mobile application changed that query to only retrieve the data that it needs. But if this query was being executed for the web application, then yeah, it didn't contain all the information it needs. So it would need to do additional calls to query for all the information that the web application would need. And that would result in additional calls. Hence why we call this underfetching of data. Now, to give you a little bit perspective of why performance and response times matters, in 2017, Akamai did a large review on 17 retailers, and they found out that the conversion rates were the highest for pages that were loaded in less than 2 seconds, and that additional time would result in lower conversion rates, and that conversion rates can actually drop to 50%. So response times really matters, not just from a, let's say, conversion rate, but also, let's say, Google search engine optimization takes response time of the web application into account when it comes to the ranking of the search results. All right, over to you, Arin.
Thanks, Donald. Yeah, that was a very good introduction to GraphQL, I would say, and setting the tone for the next slides, where we look at more details on how GraphQL works. All right, so GraphQL is all about asking for specific fields on objects from the server. So it's a way of querying data where we want to ensure that we only query data that we require. So what we can see here in this slide is on the left an example of a query where we are querying for a product with a product code, let's say 1. And what we are asking for this towards the server is to give us back the name, the price, whether the product is in stock, and the reviews with the number of stars that the product received towards the server. And on the right, we can see the response. What we can immediately see that the query has almost exactly the same shape as the result. And this is essential to GraphQL because you always get back what you expect. And the server knows exactly what fields the client is asking for. So you always are in control of what you request and in what format you get your response back in. Now, within the fields, when we see so name, price, stock, but we also see something like reviews, which is an object. And when you have an object in your query, you can then make a sub-selection of fields within that object. So we see, okay, within reviews, you can also get, you have to specify, okay, I want the number of stars for the reviews. So what GraphQL essentially does is the GraphQL queries, they traverse related objects and their fields. So they let clients fetch lots of related data in one request. And instead of making several round trips, as one would need in a classic REST architecture. So that's one of the biggest benefits that GraphQL brings to your application. Now, GraphQL is a strongly typed language, and the type system defines the various data types that can be used in a GraphQL application. So like we saw, the GraphQL query language is basically about selecting fields on objects. Now, it's useful to have an exact description of the data we ask for. So when we are trying to send a query to a server, what fields can we select? What are the kinds of objects that the server might return? What fields are available on those objects? So those are all the questions we need to ask. And that's where the schema comes in. So every GraphQL service defines a set of types which completely describe the set of possible data that you can query on that service. So when queries come in on the server, they are validated against that schema and then executed against the same schema. So you can only request for information that is exposed by the schema. So you can always you do less, but you can never do more than outside that contract. So we will do a demo now to see a GraphQL server in action. So what I have here is an example or a sample service that builds on the minimalistic e-commerce website that Donald referred in his part of the presentation. And what we can look at is, so let's look at it from a web client perspective. So a web client or a desktop client requires more data. So maybe from a product perspective, it can show a name, the images, it can show the price, the size, the inventory, and even with reviews, it can show the author name, body, number of stars. So this is all that it requires. So if we make this query now towards the server, yeah, so it looks like my Azure site needs some warming up. Waiting, yeah. Not optimal when we were talking about performance, but trust me, it's better.
It's also the afternoon for the GraphQL server.
Yeah. So yeah, so we get back a response, and what we see is again, like we saw in the query and the response types, that the query exactly represents what you expect in terms of the response. But now looking at where you want to fetch less data because you are on a mobile device and the form factor, screen size, and a lot of other things determine or sort of drive how much data you need for that for a client to work on that device. And we see in this query, we took out a lot of the stuff that we were otherwise querying here and have a minimalistic query which is fit for the mobile client. And if we now send a query, you see that's the performance. So the previous one was not really the benchmark. So we see again the response exactly mimicking what the query was. And what is interesting to note here is that in both cases, we have always connected to the same endpoint. We didn't do anything else. So if we compared this to a RESTful implementation, we would, if we had different contracts, we would have to make a different operation or a different endpoint with different operations to handle this difference in contract. But with GraphQL, that is all very flexible. We can always also look at a different scenario where, let's say we take a hypothetical case where we have a product listing page and we also have another component on the page where we show maybe the top reviews of our products. So in a REST-based scenario, you would have like two calls, one to your product endpoint to get the list of products and one to your reviews endpoint to, let's say, get your top reviews. But what GraphQL allows you to do as a client is to combine them into one query. So what we see here is we are querying for a list of products where we ask the name and the price, and we are querying for the name of reviews. Do note that compared to the previous one where we were asking for reviews for a product, so reviews were part of the product query, here they are not part and they are two separate queries. So when we execute this, we see that we get back a list of products. In this case, we see 3 products, and we get back a list of reviews. So they are essentially two different queries that was sent to the same endpoint. The GraphQL server took care of sending or forwarding the queries to the respective microservices, and we got back a combined result. So from a client perspective, we did only one server round trip to get back all the data. And this can extend to any number of queries that you can put into one, and you can let the server do the weightlifting. So that was the first look at the power of GraphQL. Moving on to the presentations. So we see GraphQL server, we've been talking about it. So we can always have a GraphQL server that exposes an API through certain endpoints. But when we think
don't
of
see the slides, Arin.
Oh, is it?
Yep, there we are.
Do you see the slides?
Yes, now we are.
Okay. So so we have like multiple services in a microservices architecture, and maybe every one of them have their own GraphQL implementation. So they are, let's say, smaller GraphQL services. But from a client, if they are still individual services, the client still has to talk to each one of them to, let's say, fetch the data. And in a microservices world, most times our microservices ideally would be domain specific and contain their own data. So the client needs to jump between services to, let's say, and then combine the data and do some to finally get usable data. What GraphQL allows us to do is also build something like a gateway. And what the gateway does, it works as a central arbiter. So it merges multiple GraphQL schemas into one schema, and which can then be queried. So what it does, essentially, it creates a consistent GraphQL schema. So and it hides the implementation details of our backend services. So it provides the consumer a sort of an endpoint with the capability to fetch data with one call. So they don't need to worry about how many services are in the backend. They look at the schema, they can make one call, they can have control on the data they fetch, so no overfetching or underfetching. So, and most importantly, no repeated fetching, because the GraphQL, the gateway can also do things like caching of results. So in the end, GraphQL primarily what it allows us to do is exact fetching. That's typically where GraphQL plays such an important role. So GraphQL essentially was created by Facebook. and then Facebook did it on JavaScript and for a JavaScript platform. Over time, the benefits of GraphQL have been, let's say, recognized by more and more people, and developers have gone on to create GraphQL implementations in different languages, and .NET is no exception. If you look up, there are quite a few .NET implementations of GraphQL, and the one we are going to talk about here is called the Chili Cream platform, and it consists of 3 parts. It has a server which is called Hot Chocolate. So that's essentially the .NET platform that can help you build a GraphQL layer over your existing and new infrastructure. There is a client called Strawberry Shake, and it is essentially a code generation tool. So it allows you to generate .NET clients for any GraphQL endpoint. And what they also have is an IDE called Banana Cake Pop. It is a tool to explore schemas. You can execute operations. You can get performance insights and everything. So the tool that we looked at in the previous demo when we were looking at the GraphQL queries and we were executing it, that's essentially Banana Cake Pop.
So essentially, Arin, it doesn't matter which client or which IDE I use, right? As long as the server follows the GraphQL implementation, I'm free to use any client or any IDE. Yeah?
That is correct. So GraphQL has a published GraphQL spec, and so long as your server implementation is conforming to that spec, you can use any GraphQL client or IDE. So if you set up your, let's say, your server using Hot Chocolate, you can still go back to use, let's say, a Apollo client on Angular or React, although the Apollo as a server is totally based on Node.js and JavaScript. So you have all the flexibility to work across platform.
Cool.
Okay, so maybe we jump into a little bit more on the demo and also look at a little bit on the code part on how we can set up a server and let's say how from a microservices perspective, bring it together in a gateway. So the examples we've been looking at where we were querying products and inventories and reviews, this essentially has been implemented with 4 smaller microservices in being put together in a gateway, giving us this interface where we could query all of this together. So if we try to look at one of the smaller services, so something like products, and if we try to execute a query there, we see, okay, we get products. But for example, if we do reviews, then we can get individually the reviews. And so similarly, and then we have the gateway, and where this is where it all comes together into this. That what GraphQL allows us to do is also inspect the schema. So what does this GraphQL endpoint expose? And a tool like Banana Cake Pop gives you a very good interface to look at the schema. So we are now looking at the gateway, and we see that from a query perspective, we can do all of these queries. So we have done products, but we could have done a query for top products or let's say something like reviews or reviews by author or by product or even something for users. So we could do all of this, although essentially all of these are part of individual microservices that are running behind the gateways. But as a client, we are not aware of those implementation details. So if we try to take a quick look at code, what we will see is, we can see here, I have 4 projects. So I have one project for accounts, which is my account API. I have one for inventory. I have one for products, and I have one for reviews. So a quick look at the code. So this is basically an empty API project, which has been, I have the package reference for Hot Chocolate ASP.NET Core being added to it, which allows me to use the GraphQL features in my project. I have my business object, which is a simple product with a product code, name, price, size, and then a list of images. What I have is a repository. This repository is doing in memory working as my data store, but you can tie it up with a database or even with another REST service. Maybe you for scenarios where you don't have control over the downstream service, so you cannot, let's say, directly query it. So you go through the REST service even. So the choice is up to you. Uh, and most essentially, we have to define a set of queries. So we have a query class, and what we said, the interfaces that we define to be exposed here. So if we look at our products, and if we look at schemas, we have products, top products, and product. And they are essentially what we do here. We say products, top products, and a get product, which is a product. And they accept some uh, arguments sometimes or without an argument, and they give back results. So essentially, how do we set it up? So after adding our NuGet package, all we need to do is from a services part, we say, okay, add GraphQL server, which is already turning our API into a GraphQL implementation. And we say, okay, which is the query type that our server should expose. In this case, it's query, and that's typically what we defined here. And then it automatically knows that it has to expose these operations as part of the query. From an endpoint mapping, it's also quite simple. Endpoints.map GraphQL, and then it knows how to map the endpoints to the /GraphQL endpoint that we see here, which exposes the GraphQL endpoint on your server. From a gateway, so this is typically how we do the microservices, but then we have the gateway. And the gateway is quite smart. We don't have to do a lot of coding in the gateway to, let's say, to make it known what microservices exist and what are the schemas and how to, let's say, put them together. It's a very simple implementation. If you look at my project here, there is just the standard program CS and my startup CS. That's all there is to it. And from here, from a package perspective, I have the hot chocolate ASP.NET Core, but I also have an extra package, that's the hot chocolate stitching. And this is what allows us to work with the gateway. So the code in itself is quite simple. So we create HTTP clients for all our downstream services. So for product, inventory, accounts, reviews. And if you remember, so first thing, it is a GraphQL server. So services, we say add GraphQL server. So it's already a GraphQL server. But we don't define schemas like we were doing in the other services through classes and let's say implementations calling to services. What we use is something called add remote schema, and we pass a reference to our HTTP client. So when this service is starting up, automatically it goes to these downstream APIs, it fetches the schema, and then puts them together in a smart way to create one big schema that then the client can use to query data without knowing the services behind it. So a quick look at how the schemas look. If we look at something like products, this is how that whole project would end up from a GraphQL implementation perspective. So we have the schema with where we said the query type was query. So we have a query. And if we follow this, the query has products, top products, and products. So the same things we saw in our code, which is now of type query. And then from here, if we look back, if we think back of our business object, which was of type product, this has also been now typed to actual GraphQL data types like integer, string, and otherwise. So it's like from CLR types to GraphQL types, there is an inherent mapping for those primitive types. So similarly, we can see for accounts, we will see that there is user. And then if we look at inventory, we will see also those operations. And then there is the whole stitched schema, which brings all of it together. And what we can see here is that we see if we look at product, so product is defined in that combined schema, but we see there are additional annotations that say the source is product, where the schema is products, and it still knows that this is what it needs to do. And what you would see here in terms of query, it has smartly put all those queries from those individual downstream APIs together into one big query object. So we didn't have to tell it how it should merge those queries. It knew exactly how to do it and put it together. So there is no repetition of types. So it can do that by itself. So it's quite smart in that way. One other thing, if when we were looking at this, if you would have noticed, is we have something called add type extensions from file, and where I pass in a file stitching.graphql. And if you look at this file, this is of a format where we say, okay, extend type product, and we say in stock of type Boolean, and we say, okay, delegate this to schema inventory at this path where we say, okay, to inventory info, we pass which accepts a unique product code. We say pass the unique product code of the product and get the is in stock information. So what are we trying to do here? What we're trying to do here is that product and let's say inventory can still be two separate services. So if product needs inventory data within its query, it doesn't have to change, neither does it have to ask inventory to change something. In the gateway, we do a smart way of delegating the query. So if we ask for the inventory within product, the gateway smartly for this particular field knows that it has to forward the request to the inventory API. And for everything else, it goes to the product API. And then when the responses come back, it puts them together and sends it back. So essentially what we saw here. So this true is essentially coming from the inventory API. So yeah, that was it from how the gateway works and how stitching works and how we can use the power of GraphQL Gateway to even to bring data together in a much faster and easy, simple way. Over
Cool,
to you,
very
Donald.
nice. Cool, very nice, Arin, and thanks for the demo. So to conclude this session, we started with let's say the common challenges of breaking down a monolithic into smaller microservices. But that microservices architecture also have their own challenges, specifically for clients, because the number of API calls it needs to do and to implement all that logic, and the number of round trips typically can become a performance and a bottleneck in terms of resources on the device. And yeah, GraphQL can help here, specifically the API gateway functionality, where you can stitch together the downstream APIs into one single schema, like Arin showed you, so that the client can query this single schema or against the single schema and return all the data from the downstream APIs. I think the nice thing about GraphQL also is that it enforces this type system, so that all the queries that are being made are actually enforced at runtime. And I think lastly, that gateway can stitch the schemas at runtime, or I should actually say at startup, Arin. So if you register a new downstream API, it will automatically stitch that schema together in the gateway and make it available towards the clients. So yeah, with that, I hope some interest has been raised for GraphQL. If you want to know more, on April 13th, that's not a joke, but it's April 13th. Arin and I have a follow-up meeting or follow-up session specifically on how to create your GraphQL server with hot chocolate on .NET. So if you're interested, feel free to join. I will share the link via social media as well. Then we're open for questions, and probably the first question is, where can I get the source code? Arin will share a link probably where you can get all the source code of the APIs that he presented, including the GraphQL schemas and the gateway logic. So with that, we're open for questions.